Okay, we're going to be looking at solving linear trig equations. And what we're going to do here is we're going to use a calculus technique, which is called U substitution. So what I'm going to do, I'm going to say let U equal sine theta. So I'm just going to change the equation and say negative 2u minus 6 equals 5u minus 3. So it makes things a little bit easier. So when I'm solving for these values, you can see I can just kind of combine like terms here. So what I'm going to do here, move all the u's to the left-hand side. So I'll subtract 5u from here, subtract 5u from here. So we're going to get negative 7u minus 6 is equal to negative 3. And then I'll keep going. I'll keep going as I'm solving a linear equation. So I'm adding 6. I'll add 6. So I'll get negative 7u equals positive 3. And then last and final step here is I'll divide by negative 7 on both sides. And I'll get u is negative 3/7. So replace u again with sine. So I'm going to say sine theta equals negative 3/7. Okay? So the next thing that you got to do is you have to think about where is sine negative. Okay, so you can think of sine as the y value. Y is negative. Where is the y value negative? The y value is negative in quadrant 3. So what you're going to do is you can draw your triangle in quadrant 3 like so. Oops, sorry, I keep deleting it, right? You draw your triangle in quadrant 3. Hold on, I'm having some technical difficulties here. All right, I'm going to draw the triangle in quadrant 3. So here we go. Choo, choo. And then I'm going to draw my triangle in quadrant 4 because I know I have a negative y value. Negative y value. Okay, so now the question is, what is the reference angle here? So I'm going to try to figure out, well, what's the reference angle here, right? What is this little baby reference angle, and what is that little baby reference angle? So the best thing to do on your calculator is to say, well, that little reference angle is equal to the inverse of, and this is important, always take the positive value, otherwise your calculator is going to throw you off a little bit. So I use positive 3/7 there. Okay, so what I can do now is say, well, if I want to know the inverse, I'm going to hit the sine inverse of positive 3/7. Just so your calculator doesn't make a mistake, I'm going to get 25.4 degrees if I round. Right, so if I want to go back, okay, I'm going to say, well, this is 25.4 degrees. This is 25.4 degrees. Okay, so our answer here is going to be the full rotations. So we have two full rotations here. So theta is equal to, this first rotation goes around to here and then plus 25.4. So I've got 180 plus 25.4. And then my second rotation is all the way around, right? So if I go all the way around, I go to here. Right? What is that rotation? I could say the other rotation is going to be equal to 360 minus 25.4. Okay, so our first rotation, which is a solution here, will be 180 minus 25.4. All right, so I'm going to do 180 plus 25.4. That's my dog, Charlie. And I want to do 360 minus 25.4. And my answers are going to be 205.4 and 334.6. Okay, so 205.4, 205.4, and then 334.6. Okay, get this 334.6. Okay, so both of these are solutions to your equation. We've got two of them that are solutions to the equation, both of those answers. Remember, your answers are in rotations, okay? Another way to look at it is if I wanted to find out, well, is this, what is this value here, right? I know that y, or sine theta, equals negative 3/7. So another thing that we can do here is, if you really like graphing here, I can turn on my sine function, right? I want to make sure I'm in degrees, right? So I want to make sure if I hit this little button up here, degrees are highlighted, and that is my domain, negative 360 to positive 360, and negative 1 to 1. Okay, and now I can graph the line here, y equals negative 3/7. Negative 3 divided by 7, and then there you go. And you're going to see all the places that it hits. Okay, so if I'm looking for just the first rotation between 0 and 360, right, I can look at it. Well, I know that it's going to be right there, right, 205.4, and then right there, 334.7, or 6 actually, 334.6. So that's another way to do it. You can graph the lines and then find the intersections in Desmos. Okay, hope this helps.